Hello, dear colleagues, students, and other friends. I'm Alexey Levchenko, Associate Professor, Department of Information Technologies in Architecture, Kyiv National University of Construction and Architecture. Our course, Modern Methods and Tools for Architectural Design at BIM, is a key subject for now. It is training modern architect and construction engineers. It is the foundation for skills that shape the future of construction. We teach students to use BIM technology. They learn to design, modeling, and management information technologies in architectural and construction and other. We focus on experimental design and adding innovation to traditional methods of learning. New design standard, BIM is very important to stay computational now. Our course builds technical skills and teamwork. Students learn to coordinate project and make smart modeling. Every year we update tasks to meet current challenge. We use different format: lectural, practical works, cloud performance, and international cooperation. This year we chose the topic of renewing panel housing. This is important for modernize Ukraine's housing stocks. Benefits of Autodesk Construction Cloud: integrate all project, better coordination, more transparency, few errors and clashes, super slot for details, design steps, support Open BIM and IFC for other software, flexible and scalable for different projects and teams. This gives students practical experience with top international tools. Our course prepared a new generation of specialists. This can bring innovation and change Ukraine's building industry. Thank you for all. And next senior lecturer, Dr. Nadia Antonenko, and PhD students, Vladislav Belov, please, and students.
Hello, I'm very glad to see all of you today, and we are ready to show you, our students ready to show you their work. And we are pleased to demonstrate it because in very hot conditions, they should work for 7-8 hours time slots. They haven't got light and electricity and internet. And it was very hard because our discipline is not only they should to start and finish their diplomas and graduated from university. I will get not much time now because some of students will be not able to continue. And please, some words from our PhD student, Vladislav, if you can.
Sure. Hi all. That was really very productive. I should mention collaborative works between students based on Autodesk Construction Cloud, and that probably will be like maybe not the very start, but good milestone in students' development further on. So very happy to be in this. in this team, let's say.
And
Okay,
I want to...
let's yeah.
Okay,
Go on.
and I want to add some words. This semester, we try to work together with Beketova, Kyiv National University of Urban Economy, and our colleagues from Texas, Dr. Nathan Hudson with his students. The next semester, we want to deepen this cooperation, and we will be able to develop the whole project together. But this semester, we try to understand how we can work with the different time. We have the difference in 7 hours, and in difficult conditions of time of warfare. Nathan, if you want to tell some words before, please, we'll be glad to hear.
No, but I've just been very impressed by the skill that the students have displayed in the modeling and the care by which they've incorporated components, both taking into account the interior and exterior spaces, and I think made a lot of progress in a very short period of time. So I'm very interested to see what the final product looks like. Thank you.
Thank you. So, students, we have every time we have built something like an architectural bureau. And the first word I want to get our BIM director, Ivan, please. Your words.
Hello, yes, I will start sharing my screen and start saying some words. You see my screen?
Yes, we can see.
Okay. Hello, colleagues. My name is Ivan Trushenko. I am the BIM manager of this group. Today, we would like to present our project, which we have been working on throughout the semester. I would like to start with the structure of the process itself. The whole group was divided into 4 subgroups, and each of these subgroups was assigned its own section of the overall project area. At the same time, I would like to share with you the structure of the files themselves. Each group created its own folders according to a specific stage. Currently, we will be working with the shared folder. We can see it there. Which is the final stage of file formation and preparation for the presentation stage. The VIP folder, work in progress, in turn, were used by students as working folders according to their preferences. Here we can see the subfolder of each subgroup, sorry, and each folder of subgroups have the folder of format in which groups were working. It's Archicad or Revit or EFC and so on. Shared folders are for the final files of the respective stages, and the published folders will be the last phase of our joint work after the presentation. Here we can see published, and it will be accomplished after the presentation. And archived, this is where all sources files and the like will be stored for further stages that may not be related to the work of our group. Work on the project was accompanied by the creation of additional rules, such as, the color scheme. I would like to show it these rules for you. So here we have color rules which students were using to format their files. The next, there was the rules for naming their files and the culture of maintaining the working files at the work process itself. So we here have some rules for naming, and as you can see, for example, we can open some folders, and here we have this naming as an example. So let's work in further. Now that we have reviewed the basic structure of the work process, I suggest we look at the overall results. Give me 1 second. Here I will show you the accomplished model of our work. We will start from the very beginning. Let's start with the starting point where we have a model of the current state without changes. So we have there the situation itself which we have in real life. This is our district, so the stage from which we began our work. The next stage of the work for the groups was to identify problem areas and propose changes. We started with the demolition of problematic elements, problems areas that are proposed. I will show you this as an example. Problem areas that are proposed for demolition are highlighted there in red color. This is our district again, and the problematic buildings highlighted red. In the next file, it's taking some time. In the next file, we see the situation still without changes, but already without the demolished buildings and structures. So without red buildings, just situation. After this stage, each group began working separately. I suggest briefly reviewing the general models, and my fellow students will tell you about the details further. Let's start from the load 100. What is lot 100? This is a model that has not yet been agreed upon. At this stage, rules for maintaining working files and color schemes were introduced with minimal detail. The next stage was lot 200. Lot 200 is an already agreed model with a medium level of detail and functional proposals. Different color means a different functional proposal, which you can see in the rules document. And the last stage is lot 300. This lot is a fully debugged model with its own classifier and calculation of proposed changes. I will show you the detail of these elements for lot 300 of different groups. This is the structures that were been in work process. Like this, and sorry, like this. And about the calculation, let's talk about them. Get back to the main folders, and I will show you this file, which is a conclusion. I may say. I will show some examples in comfort scale. So we have there the names, our elements, the the code naming of these elements, and these elements we can see in the files. The calculation in these separate files, where you can see both volumetric and numerical data, as well as the names of the corresponding classes of model elements, as I said before. And in conclusion, we have the overall volume of our calculation, and like this we have some conclusion. Yes. For this, in my words, that's all. My colleagues will tell you about more details of this project.
Okay, and who will be the next? If we are waiting, I want to tell you that this work was done by 10 lessons, and it was a little hard for us because we try to work with such projects, urban projects with first year students, masters, but they have more lessons. They have near 14 lessons. And last year we worked with this group, with Makariv, and they work with the public spaces. And because of they had that experience and they understood what is the BIM technology, we shorted the number of lectures and made more praxis lessons. Okay, I see Oleg Belinchuk want to start screen. Okay.
Yes.
Let's go.
Hi, hello everyone. My name is Oleg Belinchuk. I'm a master's degree student here at our university. And before we switch to our site, I wanted to demonstrate our very kind of, let's say, quick acquaintance with software called Autodesk Forma, which was kindly introduced to us by Dmitro Makarov. Thank you very much. Dmitro is really quite an impressive piece of software. And what's so particular about it, that it does really complex calculations rapidly. And I would say instantly, and it's a browser-based application, so you can open it in Chrome, Microsoft Edge, or whatever. But anyways, so we try to locate our overall model as precisely as possible in order to make daylight simulation and wind simulation. And what's on the screen now is basically a 3D model of all 4 sites. So it's a cumulative proposal. You see all the buildings. There are little bugs, but it's just to get the gist of how things behave climatically. And yeah, it's a great tool, I think, to really test things from the point of view of daylight, wind loads, and other things. It has a very kind of deep specification engine. You can actually specify functions, which we didn't do. So we only ran sun hours data analysis, and then I will quickly show. I don't have it in my history. The wind analysis. So you can see calculating live, basically. And you can set custom diameter for calculation area. it's very easy to relocate it and recalculate the specified piece of land, and instantly get data. So it really allows to test how things are in relation to proposal. And of course, since we didn't change much of the morphology on the existing site, it wasn't really like using these two modes of calculations at their full potential. So I guess in our case, we would have to dive deep if we had more time to specify all the functions and really get all the metrics. But yeah, this is how it is at the moment. So we've got two principal calculations. And now I'm going to pass the word to Victoria. She will start with the lot number 1, with the proposed ideas and concepts. 1 second.
Hello to everyone. I can start. Do you attend?
Okay, it's fine. In the meantime, I'm going to take over. Our presentation is split into 3 principal chapters, which are where, what, and how. In where, we talk about site. We found historical maps and give a gist of a general context. In what, we demonstrate the taxonomy of the buildings, basically the body of buildings which we've worked and focused on. And in how, we present 3 key concepts to our projects, which are the concept of wrapping, the concept of stitching, and the concept of superimposition. Where here you can see the enlarged map, satellite image of Kyiv, and what's peculiar about the site is that it's really at the edge of the city. So just to locate things, here is the central historical part. This is Podil, and this is Vinohradar. So it's really, it has this edge condition. Beyond it, it's just a forest, basically. A bit zoomed in image of site highlighting our sector. And 3 historical maps showing 3 periods of this site development, which was a really rural territory. Not much was going on. It was a mixed kind of land, sand, and land for cattle and fruit gardens. And then during Soviet period of mass construction, it was really, let's say, a factory for a new kind of mass-produced urban development. And all the residential blocks, they had monofunction, which was exclusively housing. So the housing and infrastructure, let's say, civic services. And right now, these are the images of existing site condition, and you can really see from photographs that it has a little bit of a decayed state. All of these houses are a result of a poor state maintenance program, as well as public spaces. And sometimes you can even come across of this very peculiar edge and boundary condition, where you can really see the clash of 2 scales, a private row of private terraced houses, and then next to them these massive 12 to 16 story residential blocks, with facades that that kind of drifted away from their original project by interventions of their residents, which was not necessarily a bad thing. It was out of necessity. So you can see details like hanging AC units, partially insulated bits of facades. So it really shows the entropy of this kind of development, let's say. And then opposite to the Soviet kind of project, there is this modern project which is very similar, has a very similar scale. It's just more using kind of more contemporary ways of building buildings, taller, bigger, but with slightly more infrastructure, civic infrastructure. What's also interesting about Vinohradar and other similar houses across Kyiv is that if I remember it well, at some point during 2016 or 2014, maybe there was a law that allowed residents to quickly change basically function from residential to commercial, and people really took advantage of that, and it became a tendency. So ground floor started quickly transforming into what thought was necessary there, which is also on one hand kind of entropic thing, but out of necessity, I guess. Now coming to what we have three principal types of houses on our side. First one is mass-produced series 1464A54, which is a 9-story tall house. Second one is series number 96. And then 16-story tall series BPS 6. How? So our key concepts were wrapping, superimposition, and stitching. We looked at glorious project by Lacaton Vassal, the transformation of 530
Something wrong with your sound?
We don't hear.
Sorry, I beg your pardon. Transformation of 530 flats in Quartier du Grand Parc. Some other photographs of this incredible project. It was basically a Plattenbau building, which was brilliantly renovated by French Pritzker Prize laureates. And what they did, they basically, although they added the facade, but they at the same time, to my mind, they removed it by this gesture. Because here you can see the original facade, which has this composition, let's say, of windows and other elements. So it has a really facade presence, this face. Whereas Lacaton Vassal really abstracted facade to the most radical level, and they turned facade into a space, which is really a beautiful and poetic idea. And to this extent, we think of this project as almost like a paradigm of what to do with this type of houses. Of course, it requires state funding, etc., and climatic assessment. But anyway, I think it's a brilliant precedent. And here is the axonometric. You can really see how this extension turned facade into habitable space. And what was also nice about it that it was really well accepted by the residents, obviously. So we tried to come up with a similar idea, but with a slightly different treatment, because the war really impacts everything, literally. So we couldn't avoid thinking about this factor as well. And unfortunately, this type of building is considered to be quite unstable structurally during the impact. So we thought, what if this second skin, let's say, this added space, could also serve function of protection to some extent, and the possibility to share energy. So here we show the diagram of the proposed sites for the intervention of the facade, which is basically the added terraces, and to the sides of blank walls, we give an attempt to propose basically to wrap side walls with something that could be lended out to private initiatives and potentially turned even into vertically stacked data centers that could use, that could enable this cross-utilization of heat. So on one hand, you have a blind wall, which is usually used in this context as a space for adverts. So instead of using it as a space for adverts, we propose to turn it into something that could accumulate energy, something that could be beneficial for both private and people who live in these houses. And these are similar diagrams for each of the type on our site. This is another set of references of Lacaton-Vassal, which really shows this exception of this kind of project. And this is the overall scheme showing the existing condition, then partial demolition scheme, which touches mainly chaotic and illegal structures across the avenue, and some garages. And then the overall proposal scheme, which shows the idea of wrapping with additional structural grid. And this is the list of additional programs that we envision to incorporate into ground floors to create this continuous landscape of services and added functions such as artist studios, common spaces, galleries, some veggies gardens, spaces to be let out, so spaces that are ambiguous, what if spaces, let's say, daycare center, kindergarten, co-working space, outdoor games, and perhaps even bathhouse. So yeah, the idea to really create this carpet of programs within the ground floor area. And these are our reference images just to show the intent and the direction to which it could potentially head to. These are technical, as they call it, TEP, technico-economic values. So it's basically all the metrics of the proposed scope. And then coming to the idea of stitching, which was the concept of which was again addressing this notion of safety somehow, so that people do not see Plattenbau anymore as something dangerous, something that could collapse easily, but something that has this character of support. And we realized these are two amazing references from London where additional structure was invented or added to support older structure. So we had this similar idea: what if our wrapping structure made of concrete could be stitched through the building in different directions and connected to the structure on the opposite side of the building in order to provide some kind of stability or more stability during various impacts. And unfortunately, we couldn't come up with a concrete calculation because while liaising with structural engineer, he told us that in order to calculate impacts done by explosions, you need a super powerful computer because you work with fields of particles and energy, and it really takes enormous time to. But he said that in theory, it could be a very interesting idea, and even pushed further into the idea of a car-like airbag system. So potentially it could have some even pneumatic elements to it. But again, it's a project in a project, let's say, and although it takes long time to really prove its viability, it is quite viable from our and structural engineers' point of view. Of course, it's not instant, which is a bad thing, probably. But anyways, we never know how long these buildings would last and how long the war would last. And so this is the assembled look of the structure, outer structure. Here you can see these vertically stacked data centers, or something that could produce surplus energy and make cross-utilization possible. On the example of BPS 16-story tall block. And then the last concept is superimposition, which is about a commercial part of our site. What's particular about urban planning in those days is that it was radically different from European thinking, which evolved from medieval tradition, where commercial functions and merchants were on ground floors. Obviously, this is very alien to Soviet thinking, and especially Plattenbau. So they had this idea of a community center, which wasn't really a community center in our understanding. It was just a place where all the services, like you need to stitch your shirt, you go there, you need to I don't know, there was a post office, a hairdresser, so it's basically a service center. And nowadays it evolved into a place where people just rent out spaces to basically do the same, provide services. And our idea was to keep all the functions that are there, because if they are there, it means that residents survive, let's say, they're able to pay rent, and tenants and residents really use those services. So our idea was just to renovate using, again, this concept of grid, but this time not concrete, but steel, something very elegant that could be superimposed literally on the existing structure and provide a new layer. So basically to use roofs and to rethink this inner garden bits, this alcove, and to turn this chaotic parking lot area into a public piazza. Thank you for your attention.
Thank you a lot for your presentation. Maybe the next, and after the presentation, we can make questions for all.
Okay, we will do the next.
Mm-hmm.
Can you see the screen? Hello everyone. We are working. I'm a BIM coordinator of the second team. We have worked on the second lot. So let's start. We have worked on Vinohrad residential area located on the northwest outskirts of Kyiv. The photo on the right shows the site my group worked on. Our site mainly consists of Soviet-era prefabricated apartment buildings, 2 schools, a kindergarten, and a stadium. After analyzing the territory, we found a shortage of parking spaces and public services. Therefore, on the demolition plan, we proposed removing the annexes that currently houses the one-story art school, as well as several technical structures. This allows us to build several new residential sections with public use podium and separate multi-story parking garage. Also, we followed the sanitary regulations, which required 20 meters distance between the windows of residential buildings according to the Ukrainian building laws. So the next one that when we designing the new buildings, we followed also the Ukrainian fire safety codes. They require a minimum distance of 15 meters between the walls of the building with medium fire resistances. So we combine these distances and designing the new buildings followed and combining these distances. So this slide showing you this combined constructions map with both requirements. The next one, that according to the cadastral map, a large part of the area is occupied by educational institutions. So to compensate for the school territory used for the new parking, we propose creating an accessible green roof on the top of school. The beer garden area cannot be significantly reduced, so it remains unchanged. Considering all site restrictions, we can build approximately 21,000 square meters of housing with integrated public facilities and 3,000 square meters of parking. So the pedestrian and transport circulation plan network without changing the transit route locals used to. When analyzing walking passes, we did not any non-functioning passes, so we proposed a sustainable design solution, only operating the landscaping and adding more greenery. The functional program includes 3 residential sections with accessible roofs, a podium with commercial spaces and meet local needs. The country yard for the residential sections is located on the podium roof. Office spaces on the ground floors under the residential block, a 5-story parking garage, and renovated cultural facilities. The art school expanded into an art gallery. We use green roof systems to reduce stormwater runoff and lower cooling costs in the summer. These slides show our design solution at level of development 300. We worked out the facade and structural solutions, and organized all elements according to the classifier. The housing has a typical floor plan, where only the facade column grid changed. The apartments vary based on our analysis of the district's population. We have 1, 2, and 3 bedroom apartment. 2 sections use on type H1 smoke-free stairs, according to Ukrainian building laws, with an outdoor crossing. The third section connects to the side wall, so it uses type H4 internal stairs. The stairs require a low building height, so this section has 6 floors. On the ground floor, commercial spaces and offices use the same column structure as the housing, plus a separate 6x6 grid. In the bottom left corner, we have 3-story art school with type SK1 stairs, according to the Ukrainian building laws. The parking for 126 cars must have 2 ramps, according to the Ukrainian codes. After the last presentation, we listened to students from the Austin and added a sports court on the roof to add more functional to the buildings. During the design process, we considered insulation sunlight requirements for both the schools and nearby housing. We checked this using Autodesk Forma software, and also did a wind analysis in Autodesk Forma to make sure our design did not create drafts that are uncomfortable for people. That's all. Thank you.
Thank you. Who will be the next?
Can you see my screen?
Yes, I can.
Okay. Our team has developed a proposal for the identification of the third section of the Vinogradar Microdistrict, prepared by Alexander Koba and Victoria Boyko. Let's start with an analysis of the urban planning situation. On the slide, you can see the location of the project within the city of Kyiv. The white lines mark the boundaries of the third section we are developing. With the help of Google Maps, we were able to take a virtual walk around our site. We can see that the area looks quite outdated and depressing. The facades of the buildings have chaotic extensions and glass balconies. The pedestrian infrastructure is poorly developed with no sidewalks or bike path. There are many small kiosks here. The map shows the functional concept of the area, medical facilities, and the are marked in blue, residential panel buildings in pink, pharmacies in red dots, coffee shops, cafes, and other buildings like that in yellow, and post office in green. As you can see, we removed the chaotic commerce, add 2 large commercial buildings and 1 residential complex. We will look at it in more detail in the following slides. This slide shows the areas and volumes of the residential buildings on the site. Demolition. We propose to demolish part of the chaotic buildings and extensions that clutter the site and are outdated. Later we will often offer an alternative, and the area of the buildings we propose to demolish is 4,508 square meters. This image shows the buildings that will be demolished in red. New commercial development. We propose to replace the previous 4,000 square meters of chaotic commerce with 2 commercial buildings, potentially small shopping centers. The area will be 8,150 square meters. They are shown in purple on the slide. The slide shows the first, the second, and the third floor of the shopping center. We decided to replace the chaotic commercial development. And now about new residential development.
Yeah, we design a few-story residential building with an underground parking and a green roof. In the center of the building, there is an atrium with an inner courtyard that includes rest area, children's playground, and sport area. Each floor has 1,100 square meters. So in total we have 5,000 square meters of residential space. On the first floor plans, we can see that the ground floor contains commercial spaces and entrance areas to the residential sections. On the typical floor, there are apartments. We can see that we choose a gallery type layout, and there are different types of apartments, 2 rooms, 1 room, and small smart apartments. We can also see on the next slide commercial building that we placed along the road. It helps to protect the inner courtyards from noise, dust, and cars. This allows us to create a pedestrian promenade with cafes, shops, and other commercial functions. At the next slide, we can see propose of for master plan. And next, on the renders, we can see the design of the commercial building. Next slide. Commercial building and its territory with benches, walk-in area, and plants. The commercial building has a simple form so that it doesn't attract too much attention and fits well into the general composition. Its facades are made of glass and dark black tiles. Next. On the second commercial building is also designed with dark tiles and glass panels. It has 3 floors and includes various commercial functions, an art school, shops, banks, hair salons, and other types. Next. The residential building itself using light wooden panel, panoramic glazing, white decorative plaster, and vertical green walls on the facades. We can also see the landscaping of the street with many trees, plants. This creates a cozy and comfortable environment, reduces summer heat, and provides a pleasant view from the windows. That is all. Thank you for your attention.
Thank you.
And our group. Next.
Okay,
1 second.
I can see.
Yes. Okay, good. So in our work of forming a new vision of Vinogradar, we thought not only to show a hypothetical reconstruction of the space, but also to build a holistic model of what this district could become in the near future. The basic of development was a 3D model with several levels of detail, which allowed us to study the territory both on the scale of the district in the context of the individual architectural element. In the screen, you can see our analysis of the situation of our area in our district. Next slide is it's about problem of our areas, site issues and challenges. The analysis of area number 4 reveals several key urban problems that negatively affect the quality of life and spatial environment. Chaotic parking, lack of green and recreation spaces, limited transport, accessibility to and high traffic load on nearby streets, and efficient public amenities and outdated infrastructure. These issues highlight the need for the special reorganization, improvement landscape quality, and better integration of mobility and community service. Initial data building setbacks. The analysis defines the requirements, spatial setbacks that determine the boundaries for future densification. 5 safety setbacks, sanitary setbacks, and this this slide. Fire safety setbacks, sanitary setbacks, and these parameters established the framework for further spatial planning and functional redistribution with the site. Regarding the our key tasks was to rethink the structure of functional that modern Vinogradar chronically lacks, from local shops to cafes, from leisure spaces to basic services, instead the chaotically placing these elements. We concentrate them into the single multifunctional structure, which we can see in this screen, this big building. These 2 big buildings, it was our main preposition and for the functional enhancement and urban infill. We placed the main functional areas what were missing according to the analysis into a single multifunctional center and located it. In terms of the scale of the development, we deliberately increased the number of stories of individual buildings to create the logical gradation of the urban profile and strengthen the visual composition of the district. In the next slide, you can see our calculations for this area. Total area, as you can see, more than 100
100,000. Yes.
100,000 and 10,000 square meters and more than 400,000 third meter, if I'm not mistaken. Okay, in the development of our site, we paid the most attention to the modular prefabricated new townhouses construction, high speed, low impact. In short, using modular assembly for fast, environmentally friendly, and more affordable housing, good for filling large voids. Application for Vinogradary, fast implementation of housing and services in the places where density need to be increased quickly. On the next slide, you can see our model in a lot 300 from different points of view and enlarged our townhouses, which we working on more detailing. And we placed a special emphasis of these townhouses as a segment what gives Vinogradov the opportunity to balance the scale, to combine high-rise urban density with a chamber, more private residential structure. Townhouses create a smooth transition between spacious pedestrian areas and high-rise blocks, adding a human scale and comfort to the districts. This is the format that is able to attract a new audience of residents and revitalize the district socially. That's it from our group. Thank you for your attention.
Thank you a lot for your presentation. And it was the last, yeah, Ivan?
Yeah.
Maybe
And
you want to
I
tell
would like
some
to,
words?
some conclusion words. So working in this way helps students discover their skills in extreme condition and learn not to rely on anyone but themselves. Autodesk Construction Cloud allowed us to review our activities throughout the entire working time. As a BIM manager, I found it very interesting to work on the tasks at hand, especially when you end up with a finished model that was assembled in such a short time and does not contain a large number of errors and collisions.
Thank you for your work and for work for all students. And I see the head of our department, Valery Topic, is here. Valery Vasilyevich, maybe do you want to tell some words about our students?
Да. Вибачте, тільки перебіг додому, бо тут світло. Так, я трошки початок і трошки кінець. Я думаю, вони самі про себе все сказали, вони виправилися з цією задачею. Молодці, хлопчики і дівчатка. І викладачі хороші в них. Дякую.
Thank you very much. And it was really interesting task for us and for our students because it was the first time when we give them so complicated task from very beginning, from the analysis, the site, and to the calculations of the materials. I think they work very well, and from my side and from side my colleague, I think their marks will be perfect. And now, if you have some questions, some suggestions for our next, maybe you have some new ideas, please, you're welcome. I and my students are ready to answer.
Yes, I can start. I had one question was about the wind map that I saw one presentation used a couple of presentations ago. I hadn't seen that used in that scale. I was wondering, how you came across doing that, how easy it is to have that element in, and if there's any way of assessing how accurate those projections of the wind profile of the buildings would be. Thank you.
I could answer that if.
Okay.
Yeah, thank you for your question. It's actually, it's pretty accessible. It's this Autodesk Forma, and the benefit of student version is that it's 95% full version. You're limited in precise lot data, but the buildings are loaded from, as far as I remember, OpenStreetMap data. So they're not 100% precise, but they're there. So there might be some discrepancies in heights and proportions, but from what I saw, and I spent not much time with this program, I think there's still a lot more to discover. But in general terms, I think it's a very viable tool, and it's really like intuitive kind of thing. So you can really tweak things instantly. This radius of testing or the radius of analysis, and then you can actually manipulate those datas from OpenStreetMap. So if you know that a certain building mismatches the actual height, you can adjust it. So put more hours there, and this raw data could actually be quite a precise measurement tool.
Thank you.
Yeah, and for lot 300, we have old topography plans, and students can detailize all buildings and all paths, because in OpenStreetMaps, if you work with them, sometimes they miss some buildings, some paths are not correct, and so on. So for this task, we need additive material. But for example, if we will work only at the scale of city or town or district, I think Autodesk Forma it's the good solution for the conceptual modeling. Okay, thank you for your question. Yeah, please, Людмила.
Доброго дня. Hello, everyone. Thank you for your presentation. Guys, you are done very well this work, and really impressive. And I think the main idea from this together common work between the students, it's you show like you can to work not only with tools, and you work with ideas. You implement your ideas, like architecture ideas. It's composition, it's functional. It's not only like details of the building. It's a main ideas for develop this district, rethinking this district. Yeah, and I think it's aims very well. And of course, some points can be more developed in the future, but the common work you show like this could be very helpful for architect who wants to work not independent, who wants to work in teams. It's a new paradigms and also for Ukrainian students, I think. It implements the teamwork. So, and I think it's very nice conclusions from your work. Thank you very much. And teacher also, thank you very much. You edit us for this work, and I suppose in next semester we can work together also.
Yeah, I think it was interesting experience when you wrote us your suggestion, and after that every student told us what they think about, and they told why they take in account one thing or another. And so I think it was a right way to start our cooperation, where you not was involved deeply, but your students could have this possibility to attend all lectures, to notice how our students work. And after that, you as a teachers, you can understand how to develop our common strategies in the educational process. I think it's a really good chance for our cooperation. And we have this not memorandum, but signed document of our common work. So we need to continue. Yeah.
Of course. Thank you very much. Yeah.
I see a question in the first project. Could you please clarify what you mean by data centers in the new facade extension? And have you analyzed the new insulation condition for the residential units after adding these new elements? It's for Oleg and Victoria group. Please, could you answer this question?
Yeah, sure. Thank you for your question. I think it wasn't detailedly clarified in our presentation, this data center idea. Basically, we are looking into a possibility of reusing these bland walls. It's just a windowless facade, which is used usually as a surface to be rented out for adverts, like really huge advertising banners. And we looked at what I think it was done in China. Basically, they've put data centers underwater. So we thought, why not use this, vertically stacked units along this blind wall, just to offer a new possibility of some kind of infrastructure there. So not only something that is let out, but something from which residents could also benefit. And by data centers, we meant an infrastructure that serves for machine learning and AI. And as far as I've been told, there's a rapid trend on closed AI models. So if I understand it well, ChatGPT and Gemini, they're all open models, and why is closed idea of a closed model becomes a trend is precisely because you control the data, and it's a very big trend in medicine and law, because in an open model, there is a chance if you ask ChatGPT, let's say, what's 2 + 2, and if there is a record that it was 5, it might answer 5. So it's a very it's very crucial that data for sciences such as law and medicine is very precise and controlled privately, let's say. So this was the idea behind the data center. So it's privately owned and rented out space for this infrastructure that at the same time produces a lot of heat, and this heat could potentially be used in HVAC systems of these houses. And then in terms of insulation, it's a very valid point, and we mainly introduced these deep terraces on the southern side, and on these wall-like buildings, it's a big problem when they're facing south or west. And sometimes you can even notice people that don't have blinds. They use foil to reflect heat and sunlight. So instead of glazing them, we proposed a series of shades that can roll left or right. So it's 3 shades per one unit, per one flat. So it's basically the idea of an open terrace rather than closed one, which gave us also a room to argue that it's really a kind of a common addition rather than a loggia, if that answers your question.
Got it now. Thanks. It's an answer. And maybe any question or suggestion? Okay, I want to thank you again for Dmitry Makarov, because Autodesk, they gave us opportunity work in Autodesk Construction Cloud by free to show students possibilities like Autodesk Forma, and I think our cooperation will continue in future. And thank you, all of you, and I think at this moment we can close our presentation. Thank you.
Yeah, thank you very much for your attention.
Thank you.
Thank you for invitation too. And goodbye.
Bye.
Have a nice evening.
Thank you. Goodbye.
And see you soon.